In 2017, astronomers discovered an unusual object named Oumuamua gliding through space near our solar system. This led to debates about whether advanced telescopes were needed to study it closely. However, Oumuamua disappeared before scientists could learn much about it. Now, it has reappeared, causing excitement in the scientific community and even drawing interest from Elon Musk. Where did it come from, and what would happen if it hit Earth? Join us as we explore Oumuamua's path toward our planet. There's speculation that we might be under observation, although awareness of such observations is uncertain. Elon Musk, CEO of Tesla and SpaceX, discussed a development concerning a mysterious space object known as Oumuamua, suggesting a potential direct impact in some hours. This prompts questions about the object's origin, the consequences of a collision with Earth, and potential preventive measures. The central question is whether survival is possible in such a scenario. Understanding the situation requires delving into the nature of Oumuamua. In late 2017, astronomers discovered something interesting: a super-fast object cruising through our solar system from outer space. They named it Oumuamua, a word in Hawaiian that means scout or messenger from afar, highlighting that it's the first confirmed thing from beyond our solar system to swing by. Even though Oumuamua is a big deal, we're still trying to figure out where it came from. It doesn't look like a typical space rock. It's shaped like a long cigar with unorthodox behavior. It's way bigger and more stretched out than any asteroid or comet seen in our solar system. People have different ideas about what it's made of, ranging from a solid metal monolith to a loosely held together rubble pile. Interestingly, Oumuamua sped up as it moved away from the sun, going off its expected path in a way that gravity alone can't explain. Some theories say it could be natural elements like gas escaping or getting pushed by sunlight, but others go for wilder possibilities, like a super-thin probe, maybe a solar sail, sent by some super-advanced aliens to gather information. While Oumuamua was passing through, astronomers all over aimed their gear at it, but couldn't get a detailed look because it was so fast. Still, the data hinted that it is reddish, suggesting metal minerals might be on its surface, hinting at a rocky or metal makeup. And it's not just spinning, it's doing a little tumble every 7.3 hours, adding to the mystery. Its odd shape and fast spin make it stand out from regular space rocks, keeping scientists busy trying to figure out what could be behind this interstellar visitor. Oumuamua seems to have come from the direction of Vega in the Lyra constellation. Its path into our solar system was at an angle of 6 degrees from the solar apex, which is the direction of the sun's movement compared to nearby stars, a common route for objects from outside our solar system. Some observations from the Catalina Sky Survey found its hyperbolic path, meaning it's on a course that won't make it orbit the sun. This mysterious space rock zoomed through our solar system fast, and its speed changed a lot during its trip. When it was about 2,300 astronomical units, it traveled at 26.41 kilometers per s, showing it was already moving pretty fast from where it came, outside our solar system. As Oumuamua got closer to the sun, its speed stayed steady. At 1,000 astronomical units, it was still going at 26.42 kilometers per s, proving it could keep a consistent pace across big distances. When it got closer to the sun, around 100 astronomical units, its speed increased to 26.73 kilometers per s, probably because the sun's gravity was starting to affect its path. The most significant speed change happened when Oumuamua entered the inner solar system. At 10 astronomical units, it sped up to 29.56 kilometers per s, showing that the sun's gravity had a big impact. When it came close to the sun at 1 astronomical unit on August 9, 2017, it raced at an incredible 49.70 kilometers per s, proving its dynamic and fast journey. On September 9, 2017, at its closest point to the sun, the perihelion, it hit its highest speed, reaching 87.71 kilometers per s. After that, as it moved away from the sun, its speed gradually slowed to 49.70 kilometers per s at 1 astronomical unit on October 10, 2017. As it moved away from the Sun, heading toward the Pegasus constellation, it continued to slow down until it reached the same speed it had before entering our solar system. Scientists believe Oumuamua stayed in our solar system for about 2 months. By studying how it moved and how fast it went, they discovered that Oumuamua came from outside our solar system, probably from near another star. Scientists shared that Oumuamua had a speed boost that wasn't because of gravity. They thought it might be due to sunlight pushing it, a force called solar radiation pressure. This change in speed, as mentioned earlier, happened when Oumuamua was close to the Sun. Oumuamua came from a place called Vega, but considering how fast Vega moves, it took Oumuamua about 600,000 years to get to our solar system. A long time ago, Oumuamua was far from the Sun, about 83.9 billion kilometers away, and it was going at a speed of 26.33 kilometers per s. This speed is similar to how things usually move in our Milky Way, which makes scientists think Oumuamua probably didn't come from our solar system. It might have traveled around the Milky Way many times, starting from a different part of our galaxy. Scientists want to know how long Oumuamua has been traveling in space. Maybe our solar system is the first group of planets it has seen since it left its original star system, which could have happened billions of years ago. Some ideas say it might have been thrown out of a system with a white dwarf or from a group of young stars. People also think Oumuamua could be a piece from a broken planet, making it rare. In 2020, some scientists thought it could be part of a group of icy things formed in big clouds, but later calculations made them doubt if hydrogen icebergs could survive such a long trip through space. The mystery of where Oumuamua comes from still confuses astronomers. When the Hale telescope looked at Oumuamua on October 25th, it looked red, like the core of a comet or Trojans. Later that day, the William Herschel telescope showed that Oumuamua was plain and red, similar to things in the Kuiper Belt. The Very Large Telescope confirmed this in near-infrared light, showing a spectrum like D-type asteroids. But we have yet to see Oumuamua's real size or shape because it looks like a dot of light even in strong telescopes. If it's shaped like a cigar, it might be 5 times longer than its width. If it reflects only 10% of light, Oumuamua could be around 100 to 1,000 meters long, with an average width of about 110 meters. Some scientists think Oumuamua might be made of dense rock with lots of metal, turned red by cosmic rays over millions of years. There might also be tholins, special compounds often hit by cosmic rays, making their surface red. Even though it didn't have a tail like a comet when it was close to the Sun, Oumuamua might still have hidden ice inside, protected by a layer formed from cosmic rays. In November 2019, some astronomers thought Oumuamua might be like a cosmic dust bunny made of light dust and tiny ice pieces. In August 2020, they discovered it's not frozen hydrogen, but we still need to find out exactly what it's made of. The light from Oumuamua seemed to fluctuate as it moved through space, making scientists think its surface might not be smooth. This strange behavior got scientists curious, and some wondered why it existed. One idea suggesting that Oumuamua might be from outer space focuses on how it sped up unexpectedly while passing through our solar system. This speed up couldn't be only because of gravity, so scientists started thinking it might be getting pushed by sunlight. Even though getting faster in space is not so strange, Oumuamua's speed up was more than expected, making scientists unsure about what it is. Another interesting thing is that it didn't have a visible cloud or tail, typical for comets when they release gas and dust near the Sun. The missing comet activity made some people think that Oumuamua could be a human-made object built to handle the challenges of traveling between stars. Some people believe Oumuamua might be from outer space because of its path through the galaxies. It came from outside our solar system, making it the first known thing from another star system to pass through our area. The chance of something natural from another galaxy entering our solar system in a way we can see is very low. Some people who think it's from aliens say Oumuamua might be a tool or spaceship sent by smart aliens. If Oumuamua is really from aliens, it would be a huge discovery with big ideas about how the universe works. The thought of smart aliens who can travel between galaxies makes us wonder about their technology, why they're doing it, and if they're checking out other star systems. Even though the idea of Oumuamua being an alien tool or spaceship is exciting, scientists are careful and slow in their work. They keep looking at natural explanations because saying something extraordinary like aliens are here needs strong proof. One natural idea is that Oumuamua could be a piece from a comet or asteroid, maybe from a bigger thing in another star system. Space has lots of bits and pieces from comets and asteroids, often from things crashing or getting tugged by other space things. For Oumuamua, this idea says it was once part of a bigger comet or asteroid in its home star system. Something happened, like a big crash or getting pulled by gravity, making a part of it fly into outer space. This piece, later known as Oumuamua, traveled through super big distances until coming into our solar system, showing weird things like not moving like we expect a still thing. An idea is objects like comets usually make a tail that can be seen because of gases reacting when they get close to the sun. But Oumuamua didn't have a visible tail like comets do. Some scientists think it might be a rocky piece from a comet or asteroid. They say maybe the gases that usually make a tail had already gone, or were trapped inside the object. Another idea to explain Oumuamua's behaviors is the solar sail idea. A solar sail is a way for a spaceship to move using the pressure from a star, like our sun, to push it through space. Unlike normal spaceships that use chemicals or ion drives, solar sails are quiet and use the push from light particles hitting a shiny surface. These sails are very thin and light, with a big surface covered in a shiny material, like mylar or shiny plastic, so light bounces off them, making a gentle but constant push. In the case of Oumuamua, the solar sail idea says it might be a flat and thin thing, maybe a few meters wide and less than a millimeter thick. This sail-like thing would have a super shiny surface. As Oumuamua got close to the sunlight would hit its shiny surface and push it slightly. Each bit of light only gives a tiny push, but with lots of light over time, it can make the object speed up. This push would make Oumuamua not follow just gravity, as expected, as it passed through our solar system. Also, the solar sail idea says there wouldn't be a tail like a comet because there's no gas coming out. It's all about the light bouncing off. Even though the solar sail idea is interesting, it has problems. It's hard to explain how Oumuamua spins, its shape, and how it tumbles if it's just a solar sail. Also, it needs to be clarified how a solar sail of this size could stay strong during super long trips between stars. Another guess to explain Oumuamua's features is the hydrogen iceberg idea. This guess says to 1,000 meters long, with an average width of about 110 meters. Some scientists think Oumuamua might be made of dense rock with lots of metal, turned red by cosmic rays over millions of years. There might also be thiolins, special compounds often hit by cosmic rays, making their surface red, even though it didn't have a tail like a comet when it was close to the sun. Oumuamua might still have hidden ice inside, protected by a layer formed from cosmic rays. In November 2019, some astronomers thought Oumuamua might be like a cosmic dust bunny, made of light dust and tiny ice pieces. In August 2020, they discovered it's not frozen hydrogen, but we still need to find out exactly what it's made of. An idea is objects like comets usually make a tail that can be seen because of gases reacting when they get close to the sun. But Oumuamua didn't have a visible tail like comets do. Some scientists think it might be a rocky piece from a comet or asteroid. They say maybe the gases that usually make a tail had already gone or were trapped inside the object. Another idea to explain Oumuamua's behavior is the solar sail idea. A solar sail is a way for a spaceship to move, using the pressure from a star like our sun to push it through space. Unlike normal spaceships that use chemicals or ion drives, solar sails are quiet and use the push from light particles hitting a shiny surface. These sails are very thin and light, with a big surface covered in a shiny material, like mylar or shiny plastic, so light bounces off them, making a gentle but constant push. In the case of Oumuamua, the solar sail idea says it might be a flat and thin thing, maybe a few meters wide and less than a millimeter thick. This sail-like thing would have a super shiny surface. As Oumuamua got close to the sunlight would hit its shiny surface and push it slightly. Each bit of light only gives a tiny push, but with lots of light over time, it can make the object speed up. This push would make Oumuamua not follow just gravity, as expected, as it passed through our solar system. Also, the solar sail idea says there wouldn't be a tail like a comet because there's no gas coming out. It's all about the light bouncing off. Even though the solar sail idea is interesting, it has problems. It's hard to explain how Oumuamua spins, its shape, and how it tumbles if it's just a solar sail. Also, it needs to be clarified how a solar sail of this size could stay strong during super long trips between stars. Another guess to explain Oumuamua's features is the hydrogen iceberg idea. This guess says Oumuamua night will mostly be made of frozen hydrogen. Hydrogen is everywhere in the universe and can turn solid when it's super cold and under high pressure. The idea is that Oumuamua might have come from a really far and super cold part of its home star system. In this freezing place, hydrogen gas could have become solid, making it a heavy and tight object. If that's true, this hydrogen iceberg would be super cold, maybe close to absolute zero, which could explain why it didn't have a tail like a normal comet when it got close to the sun. Another situation was explained in which Oumuamua is just space junk and not from aliens. If it hit Earth directly, it could cause a huge problem worldwide. Astronomers can't specify what it is made of, but people think it could be a heavy metal or rock object zooming through space super fast, making any hit bad. When it enters Earth's air, it could get super hot, break apart, or explode before touching the ground. If it survives all that heat, the hit itself would be destructive. The severity of the damage it could do depends on how heavy it is and how fast it's going. There's no certainty about its exact weight, but it could be hundreds to thousands of tons because of its long shape and how tight it is. A heavier thing would have a lot more energy. To get an idea, a regular nuclear bomb's energy is measured in kilotons, or thousands of tons of TNT. For example, the bomb dropped on Hiroshima in 1945 had about 15 kilotons of TNT energy. Oumuamua's impact, even if it's not a big thing, might have energy measured in megatons or gigatons of TNT, showing it could cause much damage. In the past, Earth had big disasters that caused mass extinction, like when an asteroid hit about 66 million years ago and might have wiped out the dinosaurs. If Oumuamua hit, it could be like that, causing a huge disaster and maybe wiping out a lot of life. The hit could cause instant and long-lasting damage, like big fires, tsunamis if it hits the ocean, earthquakes, loss of life, and damage to nature. The energy from the hit could also throw debris and dust into the air, maybe causing a winter-like effect. This might last months or years, messing up the climate and affecting farming and food. The Tsar bomber, exploded by Russia, was one of the biggest blasts in history, with energy equal to 15 megatons of TNT. Even though this is less than the impact of Oumuamua, it could be way worse if Oumuamua was larger or faster. The impact could be devastating, posing a global extinction threat and wiping out many species, including humans. This climate disturbance could last months or years, affecting agriculture and food production. The ecosystem would struggle, and many species, especially endangered ones, would go extinct. The collapse of the ecosystem would have a domino effect, causing negative impacts on various species. For humans, surviving such an event might be tough. The impact would cause global destruction, and those near the impact site would face severe injuries and trauma. Accessing resources like food, water, and shelter would be extremely difficult due to compromised supply chains and destroyed infrastructure. Healthcare would become challenging as doctors would struggle to reach victims. The nuclear winter would affect agriculture, leading to food shortages. Mass migration searching for food and safety would create overcrowding, resource shortages, and disease outbreaks. Societal structures and institutions would break down, resembling a post-apocalyptic scenario. If Oumuamua hit the sun instead, it would be destroyed instantly. Elon Musk has warned about the threat of Oumuamua, emphasizing the need for preparation. The mix of instant damage and long-lasting climate issues could be tough for nature. It might start a chain reaction where living things struggle and maybe collapse. After that, humans might face big problems, like injuries, trauma, insufficient important stuff, and maybe damaged supply chains and buildings. The bad effects of climate issues could make crops fail, making it even harder to get food. People who survive might have to move a lot, making places too crowded and using up resources even more. Sickness could spread easily in crowded and not-so-clean places, with insufficient medicine to help. Society might break down, causing chaos and forcing communities to find new lifeways. Even with all these problems, scientists from the government and private groups are trying to find ways to see and maybe stop big space objects from hitting Earth. Elon Musk's involvement with communication satellites sparks considerations about global politics. Musk holds considerable influence, necessitating careful decision-making. He communicates with urgency, highlighting potential challenges and calling for proactive measures. The focus is monitoring objects near Earth, assessing potential threats, developing planetary defense strategies, and exploring early detection and deflection methods. A central question arises: could Oumuamua be an extraterrestrial spacecraft from a technologically advanced civilization capable of intergalactic travel? And if so, what could be its motivations?